All right. In this recording, I want to show how to do a two-factor repeated measures ANOVA. We often see this in our human subjects designs when we're comparing men versus women, or we have two groups that do repeated measures tests. So an example of this, I'm going to go ahead and share my screen. Would be something like this. So I have 100-meter dash. Let's use the cocaine example again. The treatment that I give people is cocaine because I really think that's going to maybe improve their 100-meter dash time. And I have a placebo, which would be a sugar water, and then I have a control, which is just that they do nothing. And I actually separate the groups into men versus women. So if I were to draw this out, it would look something like this. Men, or male and female, and then I have control, placebo, and the treatment, which would be, in this case, the cocaine. So this is how I'm going to set it up, okay? So, and really what I'm actually going to scratch this, and I'm going to instead, because all of these are the types of treatments, I'm going to say cocaine. So these are all different treatments, right? Either they were treated with nothing, a placebo, or, and this we're going to say is sex. So these are the two different groups, if you will, and this is the subcategories of it. So if I go to JASP, close that. I go to JASP. I'm going to open my file, and I have it looking like this. Okay, so this is how everything looks. It looks the exact same as though it was in an Excel document, saved as a CSV file. It's a repeated measures ANOVA. And what's this? This is the treatment type. Okay. And within the treatment types, we have what? We have a control, we have a placebo, and we have the cocaine or / treatment. That's what we're going to call it. And then the second factor is sex. And we have, oh, come on, it doesn't like that. There we go. Male. And now I can scroll down, female. That makes sense. So when you set it up in JASP, it looks kind of like your boxes would. So which data set is the control male? Well, I go to right there. Which one is the control female? That's why, so this is just being picked up from what I labeled up here. So control female, placebo male, placebo female, cocaine treatment male, and cocaine treatment female. Okay. And I don't have any covariates. If I did have covariates, I could actually throw them in here. That's the cool thing about this. Okay, and we're going to look at the interaction. That's what we really care about. So it looks like between sexes, there's a significant difference. And between treatments, there seems to be a significant difference. But when I put it all together of treatment versus sex, there's not a significant difference. So we go to post hocs, and we want to do that one. Actually, yeah, that's what we're looking for right here. And down here, we can choose the different types of post hocs. And since all of them meet the requirements for doing a post of Tukey, Chaffee, Bonferroni, or Holmes, it will give us the significance for all of them. So this shows every comparison. So if I come back to here and go, what do I really care about? I probably care about those comparisons, right? I also care about that comparison. And then I'm kind of curious about this. I would expect that this one is different, but what about this one being different, right? That's what I'm kind of curious on is how does this make a difference when taking into account male and female? That's what the ANOVA is going to tell us. So if I go male control versus male cocaine, no difference. But if I looked at male control versus female control, there's a difference. So in other words, and which one is higher or lower? Well, I could go up to this descriptives somewhere. There we go, descriptives. And it would show me, I could see everything, but like I know from looking at just the averages that the females are going to be a higher time. Okay. Control male versus, so really, I don't care about the control male versus females, maybe other than control female. That was a significant difference. Placebo male versus the cocaine male, not significantly different. And then so I can look at every single comparison and it will tell me which ones were significant and which ones weren't. Right? So that's the great thing about the post hoc. So that's how you would do a two-factor repeated measures ANOVA in JASP. So again, let's just look, what's a comparison we want to look at out of all these? We want to know whether sex made a difference, male, female, in regards to taking cocaine. So I come back to this and I go cocaine treatment male versus cocaine treatment female. Yes, it was significantly different, okay, which I would expect, okay. But within females, I'm curious, does a cocaine female differ from a regular female, a control female? Well, it looks like yes. So the cocaine female was different from the control female. So cocaine made a difference with the females, but cocaine didn't make a difference with the males in this example, because I, again, just made up data. So that is how you would do a two-factor post hoc in Excel. And so just a suggestion for you, once I like to set up, if you look how I have this saved, I have a sample of a JASP one-factor repeated measure, or a JASP two-factor repeated measure, multiple regression, stuff like that. So if ever I forget, crud, how do I organize this data, or how do I run it in JASP? I can pull up one that's already been done, it's self-explanatory, and I go, oh yeah, that's how you do it. So that would be the suggestion for it. Why can't we just, I go, man, why don't I just do it in Excel? Because Excel will run regular ANOVAs, but will not do post hoc analysis. So if we wanted to know, if it said there was a difference, it wouldn't tell us where the difference is. So that's the advantage of JASP, is that it does post hoc analysis. So, all right, thank you for watching.